So now we are going to explain framework overview for Priceline. Number one, design pattern is page object model. Overview is the framework follows the page object model to maintain clean separation between UI locators and test logic. Each page of the application is modeled as a separate Java class, encapsulating all the locators and methods related to that page. This structure enhances code reusability, maintainability, and readability. Now we are going to have the detailed explanation of design pattern, which is page object model as implemented in our automation framework at Priceline using Selenium WebDriver with Java. Purpose. The page object model is a design pattern used in test automation to create an object repository for web UI elements. It helps achieve clean separation of concerns, separating page specific logic from test logic, making the test scripts more maintainable, reusable, and readable. Why do we use POM in our framework? To reduce code duplication across tests, to improve test readability and reusability, to centralize UI locator changes, that is, if an element changes, we only update it in one place, to support scalability as the application grows. Now, moving on to the folder or structure of the POM automation framework. In this, basically all the pages are under SRC test Java pages, and we have different classes for each web pages like login page.java, search page.java, booking page.java. All these have the UI locators and they are under SRC test Java pages folder. So how does a page class look like? So we are going to take the example of login page.java. In the login page.java class, we follow the page object model approach where each page of the application is represented as a separate class. The constructor of the class initializes the WebDriver instance and uses pagefactory.init elements to bind the web element defined with @findby annotations. This makes the code cleaner and easier to maintain compared to writing driver.find element repeatedly. The page class encapsulates both the locators like username field, password field, login field, and the actions like methods such as enter username, enter password, and click login. We also provide a business level method like login as, which combines multiple low level actions into a single reusable function. This way, the test script only needs to call one method for a complete login action, making the tests more readable, reusable, and aligned with business flows. If any locator changes, only the page class needs an update while the test logic remains untouched. And this ensures scalability and maintainability of the framework. Now, how it's used in test class, we are taking the example of login_test.java. In the login_test.java class, the test script demonstrates how the page object is consumed to keep the test clean, readable, and business focused. Instead of writing raw WebDriver commands, the test simply creates an instance of the login page class and calls the high level method login as, which internally performs the username entry, password entry, and login button click. This abstraction allows the test to focus purely on the validation of expected behavior. For example, asserting that the page title contains welcome after login without worrying about the details of the element locator or WebDriver actions. By leveraging the page object methods, the test becomes more concise, maintainable, and aligned with business intent, while any changes in the UI elements are handled centrally in the page class, not in the test code. This separation of concerns is one of the key strengths of page object model design pattern. Now, the benefits that we have realized in our projects at Priceline is as follow. In Priceline's travel workflow, where pages like flight search page, booking page, payment page, etc. have complex flows, POM allows us to isolate and reuse page logic efficiently. When locators changed due to UI redesign, we only had to update locator in one place rather than across all test scripts. Test classes remain clean and readable, focusing on what to test rather than how to interact with elements. Now, advanced extension. Some page classes in our framework also included wait utilities for dynamic elements, exception handling for flaky elements, reporting logs within actions, and validation methods. For example, is booking confirmed, which returns Boolean. Now, to summarize the whole section, the pattern is page object model. The structure is pages, test, utilities, config folders. Locator strategy is at the rate find by with page factory or by locators. Reusability is high with actions and elements reused across the test. Maintainability is high because centralized element management. Report integration is logging within page methods using log4j or extent reports. Moving on to the second component in our automation framework, which is test runner. We are using TestNG as test runner. To summarize, we use TestNG for executing test suites, grouping tests like smoke, regression, sanity, parameterization, and parallel test execution. TestNG annotation help control test lifecycle methods like at before method, at after suit, etc., and improve modularity. So why TestNG? We choose TestNG, which is also called Test Next Generation, as the core test runner in our automation framework because it offers robust test execution control, flexible grouping and prioritization, native parallel execution, built-in data-driven support, seamless reporting, and CI/CD integration. We are now going to discuss key TestNG features which we use in the framework. And these are as follows. Number one, test suite configuration, which is testng.xml. Number two, annotations and execution flow. Number three, grouping and prioritization. Number four, parallel test execution. Number five, data-driven testing using @data provider. Number six, retry logic for flaky tests. Number seven, reporting integration. And that was it. Now we are going to discuss each one of them in detail, kind of detail. So number one is test suite configuration, which is testng.xml. We maintain a testng XML file to define suites and test, included and excluded classes or methods, parallelism and thread count, grouping which is smoke, regression, sanity, etc. In my framework at Priceline, the TestNG XML file works like the control center for running tests. Instead of hard coding which tests to run, I define them in this file as a part of a suite. For example, I can group modules like logging and booking under a regression suite and then decide whether I want to run sequentially or in parallel. I also use it to pass parameters such as browser type or environment, which makes the execution very flexible. The big advantage is that I can trigger different suites directly from Jenkins or GitLab pipeline, which keeps our CI/CD process smooth and configurable without touching the code. Number 2, annotations and execution flow. We use TestNG annotations extensively to manage the test lifecycle. Below are the annotations and their purpose. At the rate before suite, it launch reports, load config. At the rate before test, set up browser or driver instance. At the rate before method, navigate to base URL before each test. At the rate test, actual test method. At the rate after method, log out or clear cookies or screenshots on failure. At the rate after test, close browser. At the rate after suite, flush and close reports. We use TestNG annotations like at the rate before suite, at the rate before test, at the rate before method, at the rate test, at the rate after method, and at the rate after suite to control the test lifecycle. For example, browser setup happens in at the rate before method while test execution is inside at the rate test, and cleanup or screenshot capture runs in at the rate after method. This structured execution flow makes our framework modular, reusable, and ensures test cases run independently without interference. In simple terms, I use TestNG annotations to organize my tests. For example, I set up the browser before each test, run the actual scenario in the test method, and then clean up or take screenshots afterward. It helps keep the test independent, neat, and easy to maintain. In my framework, I use TestNG annotation to control the flow of test. For example, I set up the browser and test environment in before method, at the rate before method, and the actual test runs inside at the rate test. And finally, I use at the rate after method to clean up, log out, or take screenshots if something fails. At a higher level, I also have at the rate before suite and at the rate after suite for things like initializing reports at the start and flushing them at the end. This structure keeps my test independent, reusable, and easier to maintain because each part of the test lifecycle is clearly defined. Moving on to number 3, C, grouping and prioritization. We use groups to organize tests logically, like smoke, regression, sanity, critical, etc., which enables us to run targeted suites in CI/CD pipeline, filter test during local execution. I usually tag my test into groups like smoke, regression, or sanity. This way, I can decide what set of tests to run depending on the need. Quick smoke test for a new build or a full regression for a release. I also use priorities so that the most critical flows like logins or payment always run first. D. Parallel test execution. To improve speed and simulate real world usage, we run tests in parallel using TestNG's parallel is equal to test or parallel is equal to methods with thread count. in combination with Selenium Grid, Docker containers, or cross-browser setup. We achieve significant execution time savings, especially in regression and cross-browser test cycles. Instead of running tests one by one, I configure TestNG to run them in parallel. For example, login and booking test can run at the same time on different browsers. This cuts down execution time and helps us test faster in real world scenarios. Moving on to next, E, data driven testing using @data provider. We use TestNG's @data provider feature for input combinations, that is valid or invalid logins, edge cases, example special characters, boundary values, etc., or integration with Excel utilities via Apache POI. In my framework, I use TestNG's @data provider when I need to run the same test multiple times with different sets of input data. For example, instead of writing three separate tests for valid login, invalid login, and empty credentials, I just write one test method and feed different data into it through the data provider. This way, the framework automatically executes the same test logic for all input combinations. It not only saves time but also makes the test cleaner, reusable, and easier to maintain. Next is number 6, retry logic for flaky tests. We implement a custom iRetry analyzer in TestNG to automatically rerun failed tests, especially in cloud executions where tests might fail due to network delays or UI sync issues. This reduces false negatives and make reporting more accurate. Sometimes tests fail due to timing issues or environment glitches, not because of the real defects. For that, I have added a retry mechanism in TestNG that reruns failed tests automatically. It helps reduce flaky failures and keep reports clean. Next is G, reporting integration. Extent reports and allow reports are initialized and flushed in at before suite and at after suite. Screenshot capture is integrated in @after method on test failure. TestNG listener interfaces, which are iTestListener and iSuiteListener, are used to enhance reports and logs. I've connected TestNG with reporting tools like Extent and Allure. This way, whenever a test runs, it logs each step, and if a test fails, it automatically takes a screenshot. At the end, we get a nice HTML report or dashboard, which is also linked in Jenkins for the team to review. Now, to summarize everything that we have discussed so far, below are the features and how it's used in the framework. TestNG.xml defines suite structure, groups, and parallel execution. Annotations are for lifecycle control, like @before method, @after test, etc. Grouping and prioritization are for smoke, regression, and sanity tests. Parallel execution is enabled for speed using parallel and thread count. Data providers are parameterized and DDT test, which is data driven tests. Retry mechanisms reduce flakiness with iRetry analyzer, and reporting hooks, which are linked with Allure and extent reports. So this is how we have used TestNG as a test runner in our automation framework. Now the third component of our framework is data-driven testing. To summarize it, we implement data-driven testing using Apache POI to fetch test data from Excel sheets. This enables flexible testing with multiple input sets, particularly useful for negative and boundary scenarios. Now, what is data-driven testing? Data-driven testing is a framework approach where the test logic is separated from the test data. Instead of hard coding input values into test scripts, we supply data from external sources like Excel, CSV, JSON, database, or property files. This allows the same test to run multiple times with different datasets, increasing coverage and reducing code duplication. Why we use it in our framework? Because of reusability. One test method is equal to multiple datasets. Maintainability. Data changes don't require code changes. Coverage. It supports negative, boundary, and edge cases efficiently. Flexibility. Data can come from Excel, CSV, JSON, or databases. Now, we are going to explain the framework integration. In our framework, data driven testing is achieved by combining the following. Number one, test ng's at the rate data provider for parameterization. Number two, Apache's POI for reading Excel test data. Number three, Jackson or JSON for JSON parsing where applicable. And number four, property files or database queries for environment configs or dynamic test data. Now we are going to give you an example for this implementation. Number one, Excel data provider using excelutils.java. So in my framework, I created a utility class called Excel Utils. Think of it as a helper that knows how to open an Excel file and read data from it. It has a method like get row count to know how many rows of data we have, and get cells data, rows and column to get the exact username or password from a particular cell. This way, my test script doesn't worry about how to read Excel, it just calls the utilities. It keeps the test code clean. Number two, data provider example. Next, I use testngs at the rate data provider annotation. You can imagine this as like a data supplier. It supplies multiple sets of input value to a test. For example, my login data provider takes the Excel file, loops through all the rows, and then stores them in an object array. So if I have 5 rows of usernames and passwords in Excel, the data provider will prepare 5 sets of data ready for my test method to consume. Now, we are going to discuss the third method to implement data-driven testing. Number three is test method using data provider. Now, in my test class, I simply write a small code which is shown right here. Now, this code means that instead of writing 5 different login tests manually, this single test method will run 5 times, one for each row in Excel. First iteration, username 1, password 1. Second iteration, username 2, password 2, and so on. So basically, the same test logic runs against multiple data sets. That's the power of data-driven testing. Next way to integrate data-driven is through JSON, data example for API test. For API testing, instead of Excel, we sometimes use JSON files. Here, we use JSON object mapper to read the JSON file and convert it into a Java object like a booking data POJO. Once I have that object, I simply pass it as the body of my API request in REST assured. So if the JSON file has passenger name, booking date, and payment type, the test picks it up automatically and sends it in the request. This way, if tomorrow I want to test it with different booking details, I don't need to touch my code. I just change the JSON file. So in short, Excel utils help us to read test data from Excel. Data provider acts as a data supplier for my test. Test method consumes that data and runs multiple times with different inputs. And a JSON example is the same concept but for API test where I read from JSON instead of Excel. This whole setup makes my framework flexible, reusable, and scalable because I can easily expand my test coverage by just adding more data files instead of writing more test codes. So, to give you a real world usage at Priceline, login test run with multiple user credentials, valid, invalid, empty. Booking flows test with different passenger details, destinations, payment methods. Payment module validate credit card, debit card, PayPal, and invalid payment cases. Edge cases boundary inputs like long strings, special characters, or null values. So the benefits that we have realized by using data driven concept is as follows. The benefit is it's single test multiple data set and it has reduced duplication with cleaner codes. Benefit is high coverage and its impact is covered positive, negative and edge cases easily. Benefit is centralized data and impact is easy to update test scenarios without touching code. Benefit is scalable and impact is it supports Excel, JSON, database or CSV integration. So if I explain it simply, data driven testing works like a pipeline. At the very top, we have our test data source. This could be an Excel file, a CSV, a JSON, or even a database table. Think of it as a menu of inputs for the test. Next, the raw data goes into the data providers or utility classes. These are basically helpers that know how to fetch the data. For example, my Excel utils know how to open an Excel file, my JSON parser knows how to read a JSON file, and so on. Then this data is passed down to the TestNG test methods. TestNG automatically plugs in each set of values to the test, so the same test logic runs multiple times. When the test runs, it doesn't just run once, it runs in multiple iterations, one for each data set. For example, one login test runs with valid credentials, then invalid credentials, then empty credentials. Finally, after execution, the results are captured in reports like extent report or LAO reports. These reports clearly show which data sets passed, which failed, and the overall coverage. So in short, the flow is data source, then data provider, then test method, then multiple iterations, and finally reporting. This makes it super flexible because if tomorrow I want to test more scenarios, I don't touch the test code, I just add more rows in Excel or more entries in JSON. So far, we have discussed three components of Priceline framework overview: design pattern as page object model, test ng as test runner, and data driven testing. So now we are going on to the fourth component of the framework, which is utility classes and reusable methods. This framework includes custom utility classes for browser initialization and teardown, waiting mechanism, which are explicit waits, logging, reading config files, taking screenshots on failure. These custom utility classes can be categorized as driver and environment. For example, driver manager, web driver factory, config manager, environment utility, etc. Number two, stabilizing the UI, which are wait utils, element actions, JS utils, etc. Number three, data and test inputs. which are data providers, Excel utils, Faker utils, and so on. Number four, API and backend validation using API client and DB utils. Number five, observability, reporting, and resilience. For example, reports, logger, screenshot, retry analyzer, assertion helper, etc. Number six, utilities used by POM and test. For example, file utils, datetime utils, money utils, env health, etc. Now we are going to discuss all these utility classes and all the custom classes and reusable methods within these categories in detail. So number one is driver and environment. In this framework, the first set of utilities fall under what we call driver and environment management. So basically, these utilities are responsible for setting up the WebDriver instance, like launching the browser, loading the configuration, managing browser sessions, and handling environment specific settings. Overall, this part of the framework focuses on starting and closing browsers cleanly, loading configuration dynamically, ensuring stability in parallel test runs. In short, the driver and environment utilities make the framework configurable, flexible, and environment agnostic, which is very important when you are testing across multiple platforms and environments in CI CD. So now we are going to discuss the methods in detail which falls under driver and environment category. So the first method is WebDriver Factory or Driver Manager. We have a Driver Manager or WebDriver Factory class that creates and manages the WebDriver object. It suppose it supports multiple browsers like Chrome, Firefox, and Edge, and also works with Selenium Grid or Dockerized containers when we run tests in parallel or CI/CD pipelines. The driver manager uses a thread local variable, which ensures that when tests run in parallel, each test thread gets its own separate driver instance. This prevents any test interference and makes our parallel execution stable. The benefit of using this class is deterministic teardown, fewer leaked sessions, clean parallel runs in CI. Second class we have in this is config manager. We also have a config manager or environment utility which reads configuration details from a config properties files or Maven profiles. Things like base URL, browser type, timeouts, credentials, and environment names like QA, UAT, staging all are managed from that file. This means I can easily switch between environments without touching the test code, just by changing a property or a Maven command line argument like minus "p staging". Next is stabilizing the UI. The next part of my framework focuses on stabilizing the UI interactions, and this is handled mainly through three utilities: wait utils, element actions, and JS utils. To summarize it simply, wait utils handles the when, making sure the element is ready. Element actions handle the how, performing user actions safely and consistently. JS Utils handles the fallback, fixing any tricky JavaScript or animation issues. Together, these three utilities make our automation framework highly stable, less flaky, and capable of handling complex modern UIs without unnecessary delays or manual interventions. Wait utils. One of the most common challenges in the UI automation is timing and synchronization. Sometimes the element load late, the DOM keeps changing because of AJAX calls, or the page is still rendering while the script tries to click something. So, to handle all that, we had waitUtils class, which uses explicit waits instead of thread.sleep. It includes methods like wait for visibility, wait for clickability, and wait for element to disappear. This ensures the script interacts with the element only when it's ready, which reduces flakiness and improves test reliability. Element actions. Once the element is ready, the element actions class come into play. This class is basically a wrapper around common Selenium operations like click, type, hover, and select. Instead of writing element.click directly in every test, I just call elementActions.click. Inside that method, we have added built-in waits, logging, exception handling, and even screenshot capture in case of failures. So even if an element is temporarily hidden or overlapped, the action method can retry or log the exact reason why it failed. That makes the overall framework far more resilient. The next utility method is JSUtils. And then there's JSUtils, which acts as a backup layer for very dynamic or JavaScript heavy pages, especially in React or Angular applications. This utility uses JavaScript executor to perform low-level DOM actions when normal Selenium methods don't work consistently. For example, we use JSUtils to scroll an element into view, click using JavaScript, set field value directly, or even wait until the page's ready state is complete. Sometimes we also use it to read browser console logs for debugging. So the next category we are covering for utility files is data and test input, which is also the third category. The next part of the framework focuses on test data management, and that's handled mainly through two sets of utilities. Number one, data providers with our data handling classes like Excel utils, CSV utils, and JSON utils. And then another small but powerful utility called Faker utils or random data. Data providers plus Excel or CSV or JSON utilities handle structured test data for data driven tests. Faker utils or random data handles on the fly dynamic data generation. Together, they make our automation framework highly flexible, reusable, and suitable for both UI and API testing because we can test with both static and random datasets as needed. Data providers and data files. We follow a data driven approach, which means we separate our test logic from our test data. Instead of hard coding usernames, passwords, or input values inside the test script, we pull that data from external files like Excel sheets, CSV files, or JSON. We've created Excel utils using Apache POI, which reads data from Excel cells and passes it to testng's @data provider annotation that allows the same test to run multiple times with different data sets. For example, multiple login credentials, different search inputs, or payment options. Similarly, CSV utils can read comma separated data, and JS and JSON utils is mainly used for API tests, where we store request payloads or configurations in JSON format and load them into our REST assured tests. So this entire setup makes our tests flexible, reusable, and easy to maintain because if data changes, we just update the external file, not the code. Next is random data or faker utils. Now the second part is faker utils or random data. Sometimes we need to generate dynamic or unique values like random names, email addresses, phone numbers, or booking IDs, especially in travel and finance domains where duplicate data can cause conflicts. For that, we used the Java Faker library wrapped inside a small utility called random data. It can instantly generate things like get random email, get future date, or even random credit card number for negative test cases. This helps when we want to test boundary conditions or simulate real world input without maintaining a huge Excel sheets. It's also very useful in CI/CD pipeline where the same tests run repeatedly. Faker ensures the data stays unique for each run. The next category for utility files is API and backend validation, which is also our fourth category. The next session of the utility layer focuses on API and backend validation, and that's handled mainly through two utilities, API client and DB utils. Together, API client and DB utils help us to test multiple layers of the application, not just the UI. They make our framework more robust, faster, and closer to real world testing because we can validate functionality at API and database levels without depending solely on the UI. So, in short, API client ensures our API testing is reusable and CI friendly, and DB utils ensures our data integrity checks are automated and consistent. And when combined, they give us complete cross layer testing capability for UI, API, and database within one unified framework. Now we are going to discuss API client and DB utils in details. API client for REST assured wrapper. This utility is basically a wrapper around REST assured and it helps us provide API level testing in a more reusable and readable way. Instead of writing long REST assured code in every test, we've centralized all the common things like base URL, authentication, headers, and logging inside the API client class. So whenever I need to call an API, I just use something like API client.get users or API client.postjson create booking, comma, request body. The API client automatically attaches headers, sets the correct content type, and returns a response object. This makes API testing modular and clean, and it also allows easy integration between UPI and sorry, it also allows easy integration between UI and API layers. For example, creating a booking via API and verifying the same booking on the UI. Now, coming on to the DB utils, which handles our database level validation. After we perform UI or API actions, we often validate data directly in the backend databases just to make sure everything was saved correctly. DBUtils uses JDBC connection to run SQL or PL SQL queries. It has reusable methods like get single record, get row count, get field value, query, comma, column name that fetches data from tables and return it in a map or POJO format. For example, if I create a booking from the UI, I can use dbutils to query the database and verify that the booking ID, payment amount, and status are stored correctly. This gives us end to end validation from the front end action all the way to the backend data. Now, the typical uses for dbutils would be booking IDs, payment statuses, refund trails, anything that has data integrity checks. Now, the next category of the framework focuses on observability, reporting, and resilience, which is also the fifth category that we are discussing for utility files. Now, this part, which is observability, reporting, and resilience, this category basically making sure that everything happening during the test execution is visible, traceable, and recoverable. This is handled mainly through three sets of utilities: report and logger, screenshot utils, and retry analyzer with listeners and assertion helper. This section ensures that our automation framework doesn't just run tests, it communicates results clearly, handles flakiness gracefully, and provides complete visibility into the entire execution. To summarize, report and logger captures detailed step-by-step evidence. Screenshot utility provides a visual proof of the application state. Retry analyzer and listeners handle transient features and add reliability. Assertion helper enhances reporting clarity and verification of traceability. Together, these make our framework highly observable, resilient, and audit friendly, giving both the QA and team and stakeholders full confidence in the automation results. So, now we are going to discuss the first methods for observability, reporting, and resilience category. So the first one is report or logger using extent reports or log4j. We use extent reports and sometimes allow reports for detailed, visually rich reporting. At the start of the suite, the report is initialized and during execution, every important step like clicked login button or entered username is automatically logged using our custom logging methods. If a test fails, it logs the exact step, the exception details, and attaches a screenshot right in the report. We also use log4j in parallel, which maintains a chronological execution log that's extremely helpful while debugging CI/CD failures later. So the combination of structured logging and HTML reports gives us full traceability of what happened in every test case. Then comes the screenshot utility, which works hand in hand with the reporting layer. Whenever a test fails, or even when we intentionally want to capture test evidence, this utility takes a screenshot, saves it in the report folder, and automatically embeds it into the report. So when you open the report, you can literally see the exact browser state at the moment of failure, which saves a huge amount of debugging time. Next, we have the retry analyzer and test engine listeners, which bring in resilience to our framework. Retry Analyzer automatically reruns failed tests once or twice if they fail due to temporary network delays or dynamic UI behavior. Listeners, on the other hand, help us hook into the TestNG lifecycle events. For example, on test start, on test failure, or on test success. We use them to trigger actions like logging test results, capturing screenshots, sending Slack or email notifications, or updating status back into our test management tool like QTest. And finally, we have the assertion helper, which plays a big role in both observability and reporting. Okay, I'm going to say this again. It plays a big role in both observability and reporting. Instead of using raw TestNG assertions, we use this helper class that wraps around them. It not only performs the verification but also logs clear messages to the report, showing what was expected and what was actually received. It also captures a screenshot automatically if an assertion fails. For example, when I write assertion helper dot verify equals actual title, comma, expected title, quotes, page title validation, the report will clearly show a green pass message if it matches, or a red fail message with the difference highlighted and the screenshot if it doesn't. It also supports soft assertions, which means multiple verifications can run within one test before failing at the end, making the test flow smoother. Now, the next section in our framework is all about utilities that directly support page object classes and test scripts. Basically, the helper that make our test code cleaner, faster, and more readable. These include utilities like URL router, file utils, datetime utils, money utils, and env health or preconditions. This section contains supporting utilities that make our page objects and test scripts more reliable, maintainable, and environment aware. To summarize, URL router handles navigation and route management. File utils manages downloads, uploads, and file validations. Datetime utils deal with the dynamic dates and formatting. Money utils validates financial and currency values. env health or preconditions checks system readiness before test execution. Together, these utilities give our framework a strong supporting backbone, ensuring our tests run smoothly across modules, environments, and data conditions without manual intervention or repetitive code. First, we have URL router or navigation utils, which helps manage navigation across different modules of the application. Instead of hard coding URLs in every test, we keep all the routes in one place and navigate using simple methods like navigate to quotes booking page or open module quotes payments. This makes the framework more maintainable because if any route or endpoint changes, we only need to update it in one place, not across all the test cases. Next, we have file utils, which handles all file related operations in our automation, like verifying downloads, uploading documents, validating file types, or comparing file contents. For example, in the Priceline application, we often download invoices or itinerary PDFs, and this utility helps us to verify that the file is downloaded successfully and matches the expected name or format. It also handles temporary files and cleans them up after each run to keep the environment clean. Then we have date time utils, which is extremely helpful when dealing with dynamic dates like selecting travel dates, validating booking dates, or comparing timestamps in the backend. It includes methods to get the current date, future or past dates, and format conversations. For example, it can easily generate tomorrow's date in the format the application expects, which makes date handling fully automated and consistent. We also have money utils, which is used mainly in the finance or payment modules to validate currency formatting, rounding rules, and exchange rate conversions. It ensures that monetary values displayed on the UI match the backend data down to the exact cents. And finally, there's ANV Health or preconditions, which is a small but very useful utility that checks the health of the critical services before the test suite starts. It might ping the authentication service, the payment gateway, or the database connection to make sure everything is up and running. If something is down, it fails fast and avoids wasting time executing tests in a broken environment. So, how does it all fit together? Like, what's the flow of all the utility files and the framework that uses this utility file? Now, we are going to explain how this all fit together. When I run a test, it first gets picked up by TestNG, that's the test runner. TestNG then calls the page object classes like login page or booking page, which have all the locators and page actions. Now, those page methods don't directly deal with the raw Selenium commands. Instead, they rely on our utility classes like wait utils, element actions, data utils, or API/DB helpers. These utilities make the interactions stable, reusable, and consistent. For example, instead of writing a raw driver.findelement.click, I'll just call elementactions.click. That wrapper already includes waits, loggings, and screenshot capture if something fails. Once the test flow runs, the reporting utility kicks in. That is, extend reports or Allure collect logs, screenshots, and execution status. And because everything is tied with Maven and hooked into Jenkins or GitLab CI, the whole flow can be executed automatically in the pipeline in parallel across browsers and even against different environments. So, in short, test call page objects use utilities, results flow into reports, CI CD pipeline runs everything end to end. That's how the whole thing connects together as one working ecosystem. Now, next, we are going to discuss some conventions and guardrails. In our automation framework, we follow some strict conventions and guardrails to keep the code clean, reliable, and easy to maintain. First, we follow the principle of one responsibility per utility, which means each utility class does just one thing. For example, we have a separate class for weights, a separate one for browser setup, and another one for screenshot. That way, each component stays small, reusable, and easy to debug. Second, we never use hard coded weights or thread sleep anywhere in the code. Instead, we always use our custom weight utils class, which has smart explicit weights. This helps reduce flaky tests and make execution much faster. Third, we apply a fail fast approach, meaning if a test fails, it should fail with proper context. Every failure automatically captures a screenshot, the locator, and the current page URL. So it's very easy to analyze what went wrong later in the report. We also maintain a centralized configuration file for all environment variables, URLs, and credentials, so nothing sensitive or environment specific is hard coded in the test. Number 5, since we run tests in parallel on Jenkins and Selenium Grid, all our utilities are thread safe. That means no shared mutable data or no clashes when multiple threads are running simultaneously. Overall, these conventions act like a guardrail for the team. They enforce discipline in coding, improve framework stability, and make onboarding new testers much smoother. Now, we are going to discuss the value that is delivered by this framework. The biggest value this automation framework delivers is around stability, scalability, and maintainability. First, it's very stable because of smart weights, retry logic, and safe element actions. We've been able to eliminate most flaky test issues. Tests run consistently across different browsers and environments. Second, it's highly scalable. We can run tests in parallel on multiple browsers using Selenium Grid or Docker, and we can easily plug it into CI/CD pipeline through Jenkins or GitLab. This helps us reduce overall execution time and supports continuous testing. Third, the framework is very maintainable. Since everything is modular, page classes, utilities, test data, and reports, any change in the application only needs a minor update in one place. That saves a lot of time and effort for the team. Number 4, it also provides clear traceability. Every test step is logged with screenshots, timestamps, and environment details, so debugging is quick and transparent. Number 5, finally, because it includes API and database validation utilities, it supports end to end coverage, not just the UI, but also backend and integration layers. So, overall, this framework adds a lot of value by improving speed, reliability, and confidence in every release, while also making the QA process much more efficient and developer friendly.